Hello, welcome to chapter 7, circle geometry part 2. I'll be your teacher today, Aram Nyondo. This is not new, tinagambira nabo za circle geometry, where we covered a number of parts. So kuti topic ya lero ikhale yabwino zothandiza kuti zonse zimene tinaphunzira mbuyo mu circle geometry tikhale kuti tikuzikumbukira. So today's lesson topic yathu imakatha ya lero munthu amene waphunzira ayenera kukwaniritsa kupanga establish kupeza that the angle at the center is twice the angle at the circumference. So sinayambe, let's revisit some of the terms amene tinaphunzira in circle geometry 1. Tinakambira nako za a chord, or what is a chord. Tinakambira naso what is an arc, segment, radius and diameter. Ndakaso ndaiwala mwina ma terms ena ndakambirana. So you can revisit my terms now and what they mean. Kuma kwa lero just remind one another kodi ma terms ya wamathandauza chani kumaso pasekopo amapezeka pati. Tiyambe ndi arc. So chidule tinakambirana kuti arc basically this is the arc when we have cut the circumference, tikapanga cut circumference, we have created it. Let's say we have cut here, and we create two arcs. Arc yoyamba imene ndokuti arc yachiwiri ndi iri kuntunda. So we have got two arcs, and arc yaikulu this one is going to be called the major arc, and the arc yaing'ono minor, like that. So that's what an arc is. So it's part of the circle, part of the circumference. Then tianganeni a chord. What is a chord? So basically a chord, it's a straight line imene yadula circle yathu at 2 points per circumference paja. So ikadula, let's say this is point A and this is point B, it means this is a chord. So if it cuts 2 points on the circumference, it's a chord, a straight line cutting 2 points on the circumference. So itokhala meninga khalire itokhala chonchi still condition is idule circumference athu at 2 parts, then that becomes a chord. A segment. So timagambana za chord. So when we say a chord has cut a circle at 2 parts, so if this is our chord, it means it has divided the circle into segment. So it means it has divided the circle, the area of circle, into 2 parts. So this one will be our major segment and this one will be our minor segment. So a chord line imene madula circumference at 2 parts, komano imazadula so area yathu at in 2 parts, and those areas are called segments. So we have got the major segment, ndoti area yaikulu, the minor segment, area yaing'ono ya circle imene yadulidwa ndi the chord. The radius, it's a line from the center to any point on the circumference. So this is our radius. So at any point on the circumference, and the nature of the radius is all these lines are equal, since remember the radius ndimene timagwiritsa ntchito kujambulira circle yathu, meaning the distance from the center to any point on the circumference is equal because we are using the radius. So the diameter is also a code. A diameter is a special code. Why is it special? Because it passes through the center. So this is our center, and if this one, if a chord passes through the center of the circle, that chord is called the diameter. And remember, the diameter is made up of two radii. So when you add these two radii, it gives us the diameter. So let's come back to our lesson for today. We're saying by the end of this lesson, aliyense akuyenera kuti azitokwaniritsa panga establish that the angle at the center is twice the angle at the circumference. Let's move on. An angle subtended at the center. So we have a center there, and we're going to have two lines coming from the circumference. Remember, what are these two lines? If they're coming from the center or they're coming from the circumference meeting at the center, what names do we call these lines? So as we discussed, my line now the radius. So my radius achoka pa circumference and they are meeting at the center. So they are creating an angle here, this angle. So they are creating an angle. They are meeting at the center and they are subtending, creating an angle. So this is an angle subtended at the center. So we remember tikangana buno, if we say these lines are coming from point A and point B and meeting at center O, there are two things. Remember, we can also show kuti apa pari chord yathu. Remember, a chord it cuts two parts of the circumference. So circumference yathu chord madura two parts. So A and B, imagining kuti pari line. So we can say there's a chord there. Imene ya zutsa malaini amene akakumana pa center O. Komanso titaonena kuti we have also this arc. Tikayangana, there is this arc. Arc AB. So we also have this arc. Kutoka hapo tafika hapo, we have got a minor arc here. Remember, the rugugu arc in the ikulu, that's the major arc. So we can say there is this chord imene yadzutsa malaini amene akapanga create angle per center. Komanso we can say there is this arc chord AB. So tonena kuti ndi chord AB or arc AB amene zusama line amene akapanga create a subtended angle at the center. So this is an angle at the center. When you say an angle subtended at the center, meaning there are two lines coming from the circumference amene akakumana pa center yathu ya circle. And those two lines we can assume kuti akuchoka ku chord AB or akuchoka ku arc AB. So an angle subtended at the circumference. Yamba ija timanena kuti we have got two lines coming from the circumference meeting at the center, creating that angle, subtended angle. But now this one, the lines are still coming from the circumference, comma, the angle is at the circumference. So this is an angle subtended at the circumference. If we put a letter there, C, we are saying ACB. So angle ACB, that's the angle which is subtended at the circumference. So in a kauli ndi apa angle subtended at the center, it means maana nachoka pa A ndi pa B ndiwakumana pa center. So tizitha kusiyanitsa tikanena kuti angle subtended at the circumference, it means malaini wachoka pa circumference akakumana pa circumference. And malines tikanena kuti angle subtended at the center, it means malaini achoka ku circumference akakumana pa center. Now let's combine the two to discuss the theorem. So the theorem states that the angle which an arc of a circle subtends at the center of a circle, of this circle, is twice the angle which it, the same arc, subtends at any point on the circumference. So the angle which an arc of a circle subtends at the center. Remember what an angle subtended at the center is twice. So when you say it's twice, you think it's 2 times the angle which it, we mean referencing to the same arc. So we're talking about the same points per circumference. I mean that means the angle per center, or we also means the angle per circumference. So that angle times 2 is equal to the angle created at the center. So angle at the center is equal to 2 times angle at the circumference. So angle center is equal to 2 times angle at the circumference. So basically, this is what the theorem is saying. Condition pakare same arc, or in our case, we also said it will color same chord, meaning kuti angle at the center ichote point ofanana the angle at the circumference. So angle at the center is equal to 2 times the angle at the circumference. Let's look at an illustration. Alright, so given our circle, we're saying the theory is saying we have a center there, and remember we have got our points AB that are producing my lines meeting at the center. Remember, angle imene hapa created up. This is the angle subtended at the center. Now, the angle subtended at the center, so my point omwewa, same points AB, patuluke malaini ena. Patuluke malaini ena, amene akapange create another angle there. So the condition is same points. Pamafunika pakale same points. If the same points akutumiza angle per center, the same points akutumiza angle per circumference, it means ngati angle ili x, if this angle is x, yava ikala 2x. Remember, akuti angle at the center is angle yava times 2. So if you multiply times 2 angle yava, it pasa yapa. That's a theorem, that's an established and proven fact of a relationship between angle imene imapangidwa created per center and angle imene imapangidwa created per circumference amene ali ndi same arc. So we are saying angle AOB is equal to 2 times angle ACB. So meaning this angle times 2 it pasa yapa. Same arc or chord. That's the condition. They have to be subtended. They have to come from the same arc. The subtended angles at the center or at the circumference, they have to come from the same points. Same arc or same chord. That's the condition. So using this understanding, using this equation, we can work out my angles given in any exercise or in any question. Let's look at an exercise where we are applying this knowledge. So let's look at this example. Given that O, so we have got a center O of a circle. O is the center of a circle, and the ABO, angle ABO, so this point is A and this one is B, so ABO is that one, so it's 40 degrees. So ABO is 40 degrees. Work out angle AOB, so we have AOB, and finally work out angle ACB, so that's our C. So work out angle AOB, AOB, this angle. Work out angle ACB, ACB. So we should find this angle and that angle. Now, just by looking at it, what can we see? Remember, AO is a radius, OB is also a radius. What do we see? Tikangana AOB, AOB, like that. We can see Kudavapali triangle. This is a triangle. AOB is a triangle. What type of triangle? You can see this triangle is an isosceles triangle. Why? Because OB is equal to AO, or OA is equal to OB. Why? Because all of them are radiuses. So we can start from there. OA is equal to OB. Reason, we know that they are radiuses. So radiuses, they are equal. So because OA and OB are equal, it means this triangle AOB, triangle AOB, is an isosceles triangle. So we are saying OA is equal to OB, radius. So So we have established that this they are radiuses. So they are radii. So because they are radii, it means this triangle AOB is an isosceles. So if I have this as my 40, what will come of this? So angle BAO is also equal to 40. Reason? Base angles of an isosceles triangle. Which triangle? Triangle AOB. So this one becomes 42. Now that we have established that this one is equal to this one, if this is a triangle, an isosceles triangle, it means it's simple to work out the question. The question says we should find the angle AOB. So an angle AOB is what? So we say angle AOB is equal to 180 degrees minus 40 plus 40 degrees. What's our reason? Sum of angles in a triangle. So we know that the sum of angles in a triangle ndi 180, meaning tikatenga 180 yosapo itsala ndi angle AOB. So apa this is 80 minus 180, therefore angle AOB is 100 degrees. So the question was for us to base the angle AOB. So this angle is 100. If you add 40, I would put 180, sum of angles in the triangle. Kuma the question continues. So uyu tabeza kuti this is 100. Now there was an angle there coming from the same points, angle ACB. Tipeza bwanji angle ACB. So we have found angle AOB to be 100 degrees. Now how do we find angle ACB? Apano titakukwilitsa ntchito the theorem. So angle AOB, which is our angle at the center, is equal to 2 times angle ACB. Reason. Angle at the center is twice at the circumference. So it's just a matter of TKM we have already established that AOB is 100, so 100 is equal to 2 times angle ACB. Now dividing both sides by 2, 50 is equal to angle ACB. So ACB is 50. Angle at the center, they are all coming from same angle, same points, is twice the angle at the circumference. Center, circumference. 50 times 200. Kumaso gaona kurubize yaba urabasidwa yaba, you can just divide by 2 like what we have done here. 2 divided by 100 akupatsa yaba. So atakupatsa yaba utaimsa 2 urubeze yaba, atakupatsa yaba urubeze yaba, you divide by 2. Chidule yaba is 2 times yaba. So this is the end of today's lesson. So remember, by the end of today, by end of this lesson, at least you must be able to establish that the angle at the center is twice the angle at the circumference. So takambirana ubale umeno makalira, and we have seen how mathematically kitagwiza chiro this relationship between these two angles. So next time we meet, we're going to show now the proof behind this relationship. So let's comment, ask questions, and share the lesson. Thank you. See you next week.